All right, so here we are, next video up. 2.4 rotations, and we are on page 16. All right, so quick definition. We know what a rotation is, we know what it looks like, but a rotation is a rigid motion that turns a figure about a fixed point called the center of rotation. So there's our keyword, rigid motion. That means it stays the same size and the same shape. And our center of rotation, I guess I don't really need to highlight that, but our center of rotation, unless it says otherwise, will be the origin. So the point 0, 0. All right, so you can see there's our origin. And now the angle of rotation, this is extremely important. The angle of rotation is the number of degrees the figure rotates. It'll usually be nice and easy, 90, 80, 90, 180, 270s. But here's the key. A positive angle of rotation turns the figure counterclockwise. All right, so sorry, went a little further. There we go. A positive angle of rotation turns the figure counterclockwise. So that's what we're always going to assume we're doing. Counterclockwise is that way. Okay? So this picture here, if we're kind of looking at this point, and it goes around this way, depending on the number of degrees, we're always going to make it go in that direction. Okay? So a real quick review. Now we have a new symbol. We know the little r is our reflection. And then it'll say, reflect over the y-axis or the x-axis or something. We know our capital T, or the other notation we have, means translation. And now we have a capital R. So capital R, 270, means we're rotating our image, our pre-image, 270 degrees around the origin. All right, so let's look at a few. So we've talked a lot about, whether you're going to memorize the rules or whether you're going to be kind of a more visual person. So, we talked about reflecting a point over a line, and you can just kind of go count to the line and count to the other side, and, there's your new point. You can kind of approach the rotations the same way. All right, so you can do this the way I'm going to show you, or you can memorize the rules. So I think a few of you that I've talked to have decided to kind of memorize these rules, which is another fine way to do it. But you do have other choices as well. You can do what I'm going to show you here. And, that's what I would probably suggest for most of you, unless you're really, really good at memorizing. Okay, so just so you know, those should all be degree symbols. Something came out weird with the formatting. So those should all say degrees. All right, so here's how we'll rotate. So remember, rotation of 90 degrees. We're always going to assume we're going counterclockwise around the origin. So here's how we'll do it. I'm going to call this point A. And here's really all I need to do. So I'm going to group this, and you'll see why. So I'm going to group that. Now to rotate it 90 degrees, all we really want to do is kind of visualize where this point would end up after we turn it 90 degrees that way. Okay? So what you'll do is you turn your paper exactly, you see your whole note packet, you're going to turn your entire note packet exactly 90 degrees counterclockwise. So your paper should be sideways right now. And now all we kind of do is just reset. There's our origin, there's our new origin. We're just going to pretend this is a brand new set of x, y axes, and point A is now, instead of at 4, 2 where we started, it's now at -1, -2, up 1, 2, 3, 4. So A prime, after that 90 degree counterclockwise turn, is now at the point -2, 4. All right, so we turn our paper back to where it started, and now we can plot A prime, which is -1, -2, up 4. There's A prime. So the new point, -2, 4. And now you can kind of see, if we're thinking about rotating this 90 degrees, that looks about like a 90 degree rotation. And that's all you got to do. So if you don't want to memorize these rules, this is how I would approach these. So point B, now for a 180 degree rotation. You guys know 180 degrees. We're going to turn our paper actually 2 turns to the left. There's 90. There's 180. So your paper should now be upside down. And we'll recalculate where point B is. So instead of starting up here, now you can see turning 180 degrees. Now it's at the point -1, -2, -3, -4, down 2. So B prime is at the point -4, -2. All right, and you actually, on your paper, that could be written, or it should be written upside down, because your paper should be upside down right now. So we take our paper, we turn it back to where it started. And we can plot point B prime. -4, -2. There's B prime. I'll write it down here if we want to again. -4, -2. And again, we think about our rotation. That went 90 degrees all the way 180, all the way to the other, the other side of our axis. So -4, -2 is where it ended up. You guys all right? Remember, pause, go back if you need to. I'm going quick. I don't want this video to be too long. All right, rotation at 270. Call this point C. Let me group this really quick. You probably know what I'm going to do. To rotate 270. So you can count with me. Counterclockwise turns. So turn your paper to the left. 90 degrees. 180 degrees. 270. There's our 3 turns. C prime is now basically where C is, because we mapped out, we visualized this rotation. So C prime is now at +2, down 1, 2, 3, -4. So C prime is at the point 2, comma, -4. We turn our paper back to where it started from, rotate it all the way back to where we got it from, and we can replot that rotation. So now it is at 2, -4, C prime. All the way around. Let's kind of visualize 90, 180, 270. Looks good. All right, rotation of 360 degrees. You guys know when you do a full 360 degree rotation, we're getting back to where we started from. So this point ends up, if you don't believe me, 90, 180, 270, paper back to where it started, 4, 2. All right, if you're a rules memorizer, here's our rules. And those should be degree symbols again. So this basically says rotation about the origin of 90 degrees. X, y. You negate the y coordinate and then switch them around. So this becomes -y, x. So you negate the y, and if it's already negative, remember a negative makes it a positive. So it doesn't mean the coordinate's automatically going to be negative. Basically means you switch it from what it was originally. But you negate the y, switch them around. Rotation of 180. All you do is negate both coordinates. So switch the signs, basically, of both the coordinates. For 270, we negate the x and switch them around. Okay? So if you memorize the rules, there you go. I wouldn't recommend that for everybody, but it's there for you. And pause if you need to. I'm going on. All right. You can pause and plot triangle RST for me. All right, and then we'll get back together when you're done with that. So go ahead and pause, plot those coordinates, and we'll rotate our shape. All right, so there we go. You could ignore that little thing right there. You'll see why in a second. But we're going to graph and state the coordinates. So read carefully. We're going to graph and state the coordinates of r prime, s prime, t prime. So I'm going to, write those over here so we have it. R prime, s prime, t prime. after a rotation of 90 degrees about the origin. So again, we're going counterclockwise. Counterclockwise. So I'm going to take my paper, 90 degree, counterclockwise turn. And that's what this triangle should look like after a 90 degree counterclockwise rotation. So I'm going to pause again. And I want you to record these new points kind of over here where I have this spot over the side. And then turn it back and plot. And let's see what we end up with. All right, so go ahead and pause. All right, so, hopefully you have that on your paper. There's your answer. Here's the points. I went back to my graph paper and I plotted them really carefully. And here's your check. Remember, this is a rigid motion. If your new triangle, if your image does not look the same size, same shape as the pre-image, then you know you did something wrong. So they look great. They look like the same angles, the same side lengths, and I think we're good to go. Now, one last thing. I want to talk about orientation. If you look at this original triangle, remember reading these points in order. S, T, R, S, T, R. If you kind of look at it in that order, you can see the points go, alphabetical order in this counterclockwise direction. So STR is going in that direction. Now if I read S prime, T prime, R prime, I guess I should start with R, that makes sense, right? RST, RST. If I go up to see R prime, S prime, T prime, they're still being read in that same counterclockwise order. So be really careful. Even though the points don't really look like they're in the same spot, if you look at them in alphabetical order, they're still going in the same direction. So orientation has not changed. So like we talked about, this is a direct isometry. Okay? If you want to try that one down below, you certainly can. If you feel good, you can just get your homework going on the homework check. Come see me if you have any questions. I'll see you guys next time. Goodbye.